All right, so calculating formal charge basically tells you how many electrons nominally belong to the atom that you're looking at, like as in how are they shared. So the formula for formal charge is that you take the number of valence electrons that the atom should have, as in the ones you add up when you're making the Lewis structure in the first place. Then you're going to subtract from that number of valence electrons it starts with half of the electrons that are shared in bonds, okay? So I just would say half of the bonding electrons, okay? Because remember, each bond in a Lewis structure contains 2 electrons. So if you've got a bond between 2 atoms, say carbon and hydrogen, nominally out of those 2 electrons forming the bond, 1 belongs to the carbon, 1 belongs to the hydrogen, right? So they're sharing. All right, and then you're also going to subtract off from that total number of valence electrons that the atom has, how many of those electrons are in lone pairs. So you're just going to subtract off the lone pair electrons, okay? So let me do an example then with this carbonate ion, okay? So I'm going to try and keep it in line with the way Alex has laid it out here. So the number of valence electrons, and then we can subtract from that half of the electrons that are in bonds. Sometimes you might see this written somewhere as just subtract off the number of bonds, which is essentially what you're doing, right? Because each bond contains 2 electrons. But I do want you to think about it in terms of like number of electrons, not number of bonds, okay? And then you're going to subtract off the lone pair electrons. Okay, so for the central oxygen then, just to draw your eye to it, the central oxygen is this one right here. So oxygen always has 6 valence electrons. And in fact, while we're here, why don't we just go ahead and fill that out for all the oxygens, right? Carbon always has 4 valence electrons, right? Come back to you in a minute, carbon. Okay, so then that oxygen is involved in 4 bonds, which contain a total of 8 electrons, okay, which are shared. So half of those 8 electrons belong to that central oxygen. So half of 8 is 4. And then it has 0 lone pairs of electrons. So 6 minus 4 minus 0 gives me a formal charge of +2. All right. So then let's look at this other oxygen. So the right oxygen. So let me draw your eye to that one now. This bad boy over here. Okay, so it's oxygen. So it always has 6 valence electrons to start with. And there's one bond there which contains 2 electrons. So half of 2 is 1. So -1 for the bonding electrons. And then it's got 2, 4, 6 electrons in lone pairs. So 6 minus 1 minus 6 gives me a formal charge of -1. All right, so then let's look at the other bottom oxygen. So that'll be this one, okay? And you can take a shortcut when you've done a few more of these. You can see it's going to be the same, right? Because it's got 1 bond and 3 lone pairs, which is the same bonding situation as the right-hand oxygen. But just to follow it through, there's a bond. The bond contains 2 electrons. Half of those electrons belong to that oxygen, so half of 2 is 1. And then subtract off the electrons that are in lone pairs, which is 2, 4, 6. 6 minus 1 minus 6 is -1, okay? And then lastly then, who have we got here? The carbon. Hello, carbon. How are you doing? All right, so this carbon, then we can see there's 2 bonds because there is a double bond there. So carbon has got 4 valence electrons. We've got a total of 4 electrons in bonds, but they are shared between the carbon and oxygen. So half of the 4 is 2, so subtract off the 2. And it's got 2, 4 electrons in lone pairs. So 4 minus 2 minus 4 is -2. Oh, okay. So let me just put these in here so you can see them in the table. So a little thing about formal charges, which the question isn't specifically asking you, but just so that you are aware, formal charges for a Lewis structure should sum to 0 if you have a neutral molecule. If you have a polyatomic ion like this, they should sum to the charge on the ion. So let's just check. They should sum to -2. So the carbon is -2, and then that central oxygen was +2. And then each of those peripheral oxygens, the one on the right and the one on the bottom, is -1. So -1, -1. That actually does sum to -2. Okay, so those formal charges do seem to be okay.